We are making a video about Abell 1. Since we finished the Messier Catalogue, I thought I would follow the lead of my illustrious colleague, Professor Merrifield, who's branched out into looking at other catalogues. The obvious catalogue for me to talk about is the one that I've probably used the most in my career, which is the Abell Catalogue of Galaxy Clusters. And I thought I'd go and figure out what Abell 1 was, because it wasn't one I was familiar with.
So the Abell Catalogue isn't a catalogue of individual objects, it's clusters.
Yeah, so the cluster is the object, but it's a concentration of objects, a concentration of galaxies. And just like with the Messier Catalogue, if we have a list of these things, we can go off and do exciting things with them. There's a lot of history in this video. And it was really, really interesting for me to go away and read about this because it all starts from the Palomar Sky Survey. So this is a big survey that took place at the Palomar Observatory in Southern California in the 1950s mostly. And it was at a time where A, we had photographic plates, so we were able to take records of large patches of sky, and B, there was a specific kind of telescope called a Schmidt telescope, the design of which was optimized for covering wide areas of the sky at once. So the idea here was to put this technology together and do a really big survey of as much of the sky as was possible that would then act as a repository for astronomers to do work on and to understand, what was out there, basically, rather than targeting specific objects to look at. But no one telescope on the surface of the Earth can see the whole sky. This was a survey that did start in the north, and they did most of the northern sky down to a declination of minus 30 degrees. They got quite a long way into the south. It was finished later by using another Schmidt telescope in the south, and then it covered the entire celestial sphere. So now let's introduce Abell. George Abell, he was a student at Caltech, the California Institute of Technology, and he was employed to work on this survey. He was one of the observers. His job was literally to look at plate after plate after plate and note down anything interesting. He literally had a little card file of interesting objects that came along. So actually, I should qualify this video, there are two objects called Abell 1, because the first thing he did was make a list of planetary nebula. So he made a list of 86 of them, most of which were later confirmed. But we're not going to really concentrate on that Abell 1 right now. If you go and look at it, it is kind of boring. It's a little disk, kind of reddish in color, really featureless, just marks the end stage of a star's life. But as he was going through this project of looking at all these plates, he noticed that there were a lot of clusters of galaxies. So the galaxies weren't uniformly distributed. There were very obvious regions where they were sort of clumped together. And he thought this was interesting. Now here, this is where I had a lot of fun researching this video, is that we can actually go to Abell's words himself to hear what he thought about this and how he came up with this idea. Because the American Institute of Physics has for a long time conducted really in-depth oral histories, interviews with prominent physicists, which are now available. The transcripts are available, and they're really long. They're really detailed. They go into everything from their early childhood and education to the really nitty-gritty of what they were doing, but also, why they were doing it, what it was like at the time, who else they were working with, what sort of feuds and personalities were involved. It's like all the gossip. So I had a look back at Abell's interview, which was really interesting reading. First of all, the interviewer made a point that is the sort of point you might make, Brady, which says, it sounds like it must have been a very tedious job. But Abell said, oh no, it's very exciting to look at the plate. I was the first person to look at these plates. And I think that's kind of neat, the idea that you are the first person to see these objects that are out there in the universe. So that must have, that sort of motivation must have sustained him for a while. In terms of the idea of the clusters, what he said was, during that time, I was impressed with how many clusters of galaxies kept showing up. I thought this was an interesting thing, and I was keeping lists of them anyway. So it occurred to me, why not make a complete survey of the distribution of these rich clusters? So I organized that thing, probably around the end of the first year, and submitted a thesis proposal, which got approved, and I did it. And so that was his PhD work. That was his thesis, to compile this catalog of clusters. And to do something like this, you don't just write down everything you see. For a catalog to be useful, it has to have really clear criteria. So he set out these rules of what a cluster had to be in order to make it to this list. And that allows other astronomers to use that list with confidence that they are getting a clean sample, that they're getting a well-described sample, and that any statistical analysis they do will be meaningful and unbiased.
I'm just going to say this. That sounds like an easy PhD to me. Am I wrong?
I don't know what the standards of astronomy were like at that time. I mean, nobody had ever done this. This was new information. He made some conclusions derived from that catalog, which advanced the field somewhat. But, the pace of astronomy was really, really different back then. And the big work was being done at the telescope, actually taking the data. We're so far removed from that now. Even in the timescale of my training and my career, we've become quite divorced as professional astronomers from that staying up all night doing the work at the telescope. And we download catalogs and we play with things and we write computer code. But they couldn't do that. We're a really data-rich field right now, but this was the front line. If we were going to do astronomy, somebody had to be up at the telescope collecting those photons. They were all precious.
I always feel like one of the great insults you can make to a scientist or a field of science is to call it stamp collecting. And this feels a lot like stamp collecting. Don't get me wrong, it's cool, it tickles my brain. No one loves lists more than me, as evidenced by my work. But it does feel very stamp collecty. Is this thing useful? Do you still use it?
I still do use it. I mean, you have to think, he started from a position of looking at the universe in a way that nobody had been able to look at it before, because we just hadn't had this wide field view of so much of the sky. And he made an observation. He made an observation that the galaxies seemed to cluster. And then beyond that, he made an observation that he thought there was second order clustering, that the clusters clustered. And now we're getting into questions of cosmology. What kind of universe do we live in? How does structure form in the universe? And remember, this was the 1950s. The model of cosmology was far different. Their understanding of what the universe was far, far different than the detailed understanding we have today. So no, I don't think it's just stamp collecting. I think it's stamp collecting as a first step, because that's how you impose order onto knowledge. And then it's trying to find patterns and trying to find understanding from your stamp collection.
That's cool.
So we've talked about Abel's work as a graduate student doing this PhD, but he was a very eminent American astronomer in the 20th century. He was chair of the University of California, Los Angeles Astronomy Department.
By selecting among various optical arrangements, the telescope can be used in a variety of ways.
He played a big role in both education and public understanding of science, which I feel is kind of meta here, because we are having an interview about the business of doing science using an oral history where someone sat down with an interviewer talking about the business of doing science.
The photographs taken for this Palomar Sky Survey revealed the images of hundreds of millions of individual galaxies.
He also had a connection with the UK because he worked up in Edinburgh quite a bit. And he made films with the BBC. He was an early advocate of doing popularization of science because he thought it was valuable for the public to understand this work. So he made a series of programs with the Open University and the BBC. And I learned that the observatory at the Open University here in the UK is named after him. It's the George Abell Observatory, which I thought was kind of nice.
Are we nearly at Abell 1?
Well, honestly, I don't have much to say about Abell 1, Brady, because I looked it up and there is nothing special about it. It is a little cluster of galaxies. And I did the usual thing where there are databases where you can say, here are all of the papers that have referenced this object. And sometimes it can be hundreds and hundreds of entries long. There were 16. Most of them, it's an entry in this catalog. Here's a catalog of clusters. Here's a compilation of something else. No one, to my knowledge, has ever looked at it as an individual object and studied it in that perspective, which made me feel kind of sad for it, to be honest.
Well, if only you knew an astronomer. Oh,
If
hang
I
on.
knew an
Why don't you do it?
So what I did was this original sky survey that we're talking about, it was in photographic plates. And this is something that big observatories used to have a collection. Like there'd be a room you could go and look at you get the plate out that you wanted to. This was before my time, but you'd go to the plate collection, get the plate out, take a Polaroid picture of it, and then take that with you to the telescope as sort of your map of the sky. But in the 1980s, this survey, and there was a successor survey that was done again with better technology, an all sky survey in the 1980s, the sort of Mark II. These two surveys, all of the photographic plates were digitized. So they were scanned, and they were scanned in such a way that the digital copies could be used for science. They weren't just sort of, take a picture and stick it on the wall. So we can now access these. So I thought I would download and have a look at the actual data. There were two plates taken of each piece of sky, one in a blue filter, one in the red filter. He did all his work on the red filter. So here is the digitized scan of the plate that Abel would have looked at when he was doing his inspection. That's Abel 1. And I'm going to change this a little bit. I'm going to invert the color map because this is what Abel would have seen. So in this case now, dark means something that's bright, and it's just a little bit easier for our eyes to see contrast. Because it's digital, I can change the color scale and I can bring that contrast out so you can see a little bit more fuzzy detail. Abel wouldn't have had that capability. And so here's a galaxy. The thing next to it with a little cross indicates that that's a star. So that's in our galaxy, and that one's much, much further away. If we zoom out, you can sort of see the whole plate. You can see how big it is. And yeah, perhaps you can guess that there is some sort of concentration of galaxies here. Now, to get into Abell's catalog, the criteria he used were there had to be at least 50 members. They had to be within a certain radius that depended on the distance to the cluster, but it was quite a generous one, so it was quite out here. And they had to be 50 between the brightness of the third brightest galaxy and 2 magnitudes fainter. So magnitudes are a funny unit that astronomers use to measure brightness, but essentially sort of a factor of 6 in flux and brightness. And so, so there's 50 of those galaxies in that region.
49 you don't get in.
49 you don't get in, because otherwise, well, to be honest, I think some of the criteria were a little bit generously applied. But generally speaking, you have these rules for a reason. Some get in, some don't. And then you have your catalog. So there you go. That's just Abell 1.
So we don't know if they're spirals or ellipticals or barred. There is no greater zooms that have since been done with Hubbles and things?
No, there's no Hubble data. The Sloan Digital Sky Survey didn't cover it. Nobody's gone through and classified those galaxies, at least not that I could find in the literature. That's it. It was pretty much Abell and now us, as far as I can tell.
Oh, we've got to get a closer look. Can you get us some telescope time?
Well, to get telescope time, I'd have to have a reason why. And so I'd have to build a case as to for why it was worth spending expensive time to look at this object. And a better look isn't quite going to do it.
We could do like a Kickstarter or something and buy the time. Can you buy telescope time?
Not on any of the telescopes that I'm familiar with. I need to pause here. I've been a bit unfair because, of course, I've been talking about professional astronomers. I've been talking about the kind of telescopes that we put on top of mountaintops and the results that get published in journals. That is not the only kind of astronomy that gets done here. So I want to take back that statement I just said, because I know that there are people we might call amateurs, but are very, very skilled, who have observed Abell 1, who have beautiful photos of it, and have probably looked at it and thought carefully and deeply about it. So I don't want to diss the contributions of any of those very important people. But speaking from the sort of professional sphere, yeah, that's what we got. But I thought this would be interesting. So the reason I started this video is I said I have used the Abell Catalogue many times, and that's because I study clusters of galaxies. And the Abell Catalogue encompasses all of the nearby clusters of galaxies, okay, the ones that we've been able to see, for quite a long time. And for some of those are as familiar to me as my own address. So Abell 2218, Abell 2219, Abell 1689. If you showed me a picture of them, I would recognize them instantly. And so I thought it was quite interesting, the anonymity of Abell 1 in contrast. And I know you can see over my shoulder right now that poster, which we've made a video about before. This is a patch of sky that has 2 Abell clusters in it. So Abell would have gone through this patch of sky as well and put 2 different objects in his catalog.
Which 2 Abels are in it?
Well, do you want to come over and see?
Yeah.
So this is, of course, not the picture that Abell would have had. Okay?
Yeah.
And so when he went through this, he thought there was 1 cluster of galaxies up in this region, Abell 901, and 1 cluster down in this region, Abell 902. Now, this field got the luck of the draw, unlike Abell 1, because myself and some of my colleagues decided to focus on this. And we spent 10, 15 years working on this patch of sky, and we've looked at it with lots of different telescopes, including the ones that have made this image. With Hubble, we've seen all sorts of different wavelengths, and we've learned so much about the structure and all of the individual galaxies here. But we also learned that Abell didn't see the whole story, because where he saw 1 collection here, we now know that there are 2 very distinct different clusters of galaxies, and the whole thing makes up some sort of supercluster, which was exactly the sort of thing he was pointing out he thought existed. So I thought I'd drag out the images from the Digital Sky Survey and have a look at that as well, just to see what Abell would have seen when he made that determination. And here, I love this because you can see it's actually the corner of the plate. And you can even see the label up there. It's a National Geographic Society, because the survey was funded by a grant from the National Geographic Society. And it says Palomar Observatory Sky Survey. And so right there in the middle, you can see the same region we've just seen up there. And this is essentially the region he thought was 1 cluster, and the region he thought was the other is down off the bottom of the screen. Look how ropey it is. You can see all these artifacts. It looks like a bit of, I don't know, dust or something.
A hair or something?
A hair or something like that. This is the real deal. This is the actual stuff that he would have been looking at. And it's not that he got it wrong. It's just that to the level of information that he had, he made 1 determination. And when we looked a little bit more closely, we could see a lot more richer detail. Maybe that would be the case with Abell 1 as well. I'm sure there are lots of interesting things lurking there. We just don't know what they are.
How did he decide it was number 1? Did he start at the North Pole like we do with Caldwell, or?
So they are ordered. They are in a list, which is very pleasing. And the order is in right ascension. So this is the astronomical coordinate that is analogous to longitude on the Earth, but up on the celestial sphere. It's the one with the lowest right ascension, the one closest to 0. That's it. That's why it's in there at number 1. It's not Greenwich that we use for our 0 point there. It's the position of the sun at the spring equinox. Very arbitrary. But this is another thing. The coordinates he would have been using are not the same as the coordinates we use now, because the orientation of the Earth is moving relative to the fixed stars. There's a precession. So every few decades, we have to sort of update what we mean by all of these coordinates. So that's in the coordinates of the epoch that he was working in back in the 1950s, which might not be the same as the ones we use now. We had a conversation about whether this was stamp collecting or whether he was gleaning some understanding of the universe. And we talked about the superclustering of galaxies, which we've seen illustrated over here. And again, that wasn't a widely accepted idea before he introduced it. And in fact, one of the big astronomers in California at the time, Fritz Zwicky, who we know as being one of the first people to postulate that dark matter existed. We also know him as someone you might politely refer to as a strong personality or a character. This is what I love about the oral histories, because it makes all of this human side of science come alive. So Abel worked in the same sphere as Zwicky, and Zwicky was adamant that clusters were uniformly distributed. So this idea that there could be superclusters of galaxies, that clusters could themselves be clustered, he was dead against right from the beginning. And it's really interesting to read how that sort of argument developed and to get a sense of the personalities involved. So there's lots of stories about Zwicky, but I really liked what Abel said about him. He said, "I got to know Zwicky very well. I always liked Zwicky. He was a lot of fun, but he would be an impossible person to take a course with. He was an egomaniac, to be sure, but he made a lot of contributions, a bright guy." And this phrase is brilliant. "If you could buy Zwicky for what we think he's worth and sell him for what he thinks he's worth, you'd be a millionaire." But nevertheless, that doesn't detract from the fact that he was also a great man. There you go. These are people doing science. They're not robots. And it was clearly a very exciting time to be part of all of this endeavor.
Here's another list we really like here at Deep Sky Videos. These are most of our Patreon supporters, people who make contributions each month, no matter how small, to help keep our channel going. If you'd like to join them, go to patreon.com/deepskyvideos. It means a lot to us, but no matter what, thank you very much just for being here and watching our videos. Do share them with your friends, give us a like, make sure you subscribe. It all helps keep the channel going.
About 50 by 100 light years, so that's still fairly hefty as well. It's a stellar nursery, so it's got all the raw materials to form young stars. The reason it glows is that it's full of ionized hydrogen. So there's so much radiation from the hot young stars that are being born